What's going on, guys? Today we're going to learn how to solve some right triangles. Today, some of our learning targets is I can use trigonometric ratios and the Pythagorean theorem to solve right triangles and apply problems. And I can use sine, cosine, tangent, secant, cosecant, and cotangent to find missing angles and side measurements. Alright, so before we get into this, there's some stuff that you need to know. Like that SOHCAHTOA. One great way to remember this is some old hippie caught another hippie tripping on acid. Or sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals the opposite over adjacent. And I'll explain that a little bit later on, but let's see what's going on. Some more things you need to know is the angle of depression and angle of elevation. I'll explain those later, but yeah. Alright, so here's our first problem. Solve triangle ABC if angle A is 36 degrees and side C is 10 centimeters. So, I got this brought up, and what we're going to want to do, first you can go any direction with this. First you can solve this missing angle right here. It's pretty easy because you have your 90 degree symbol there, and you have 36, so you have 90 plus 36. It's going to bring you to 126, and you go 180 minus 126 gets you to 54. So now you have angle B. Simple enough. So now what you need to do to solve for side A and side B is what you can do. So you're either going to use one of three things: sine, cosine, tangent, or tangent. And usually, for now, you can use either one of these, but right now we can't use tangent because we don't have the opposite angle or the adjacent angle to the 36 degrees or the 54 degrees. So tangent's out of there. Now what we can use is sine or cosine. For now, let's use sine. So what you're going to do is you're going to set it up to where it says sine 36 equals, so since it's sine, it's going to be opposite over the hypotenuse, so A over 10. So to solve for A, you just use basic algebraic skills and then just multiply by 10 on each side. And then what you're going to want to do is put that in a calculator. So 10 times sine of 36. So then you're going to get about 5.878. So A equals about 5.878. So there you go. Now you have A. So now from here, what you can do is multiple things. You can either solve for B using cosine, or you can solve for B by using Pythagorean theorem. So for now, let's use cosine and try to solve for B. So now what we got is cosine of 36 equals E over 10. Again, basic algebra skills. Multiply that over. So then you're going to get about 8.09 for B. And then you basically solve for the whole triangle. Alright, so the next on our in our lesson plan, we have another problem. Find the angle of D on triangle dog when line OG is 3 and line DG is 7. So let's draw a little triangle here. So now that I've drawn it out, what we're going to do is we're going to try to find angle D right here. So how to find that is we got to figure out what we have. So obviously we have the 90 degrees, then we have two sides. Now what we could do is we could solve for the hypotenuse if you wanted to, but that's just a longer way of doing it. So instead you got to find what trigonometric equation will use the opposite and the adjacent sides. So that'll be tangent. So the tangent of angle D equals 3 over 7. Now, this is tough because you can't just divide by tan because it's actually an entire function. So it's sine and cosine. So you can't just divide by them. But what you can do is multiply it by tan to the negative first power. And then that'll cancel out the tangent. And then you can throw that on your calculator. So tan of 3 over 7. Then you'll get about 23.2. So there you go. And that's your answer. 23.2 degrees. There you go. Easy enough. So now, next up, we have another problem. This is when we're going to start seeing stuff about like the angle of depression and elevations. So here's the problem. A traffic helicopter is flying 100 or 1,000 feet above the downtown area. To the right, the pilot sees the baseball stadium at an angle of depression of 63. To the left, the pilot sees the football stadium at an angle of depression of 18 degrees. Find the distance between the two stadiums. So I got my little helicopter up here and a little pilot. He's just chilling, just flying and stuff. So first, let me talk about the angle of depression and elevation. The angle of depression or elevation is usually used in a word problem when someone's trying to find how far or how tall or something is. So the angle of depression is when someone's looking down at something, like the pilot looking down at the two stadiums, or if someone was on the ground and looking at the top of the Empire State Building, trying to figure out how high it is. Great way to remember that is the angle of depression always gets you down, or depression always gets you down, and the elevation is usually goes up. So now what we're going to do is we're going to try to find, for now, the distance between the baseball stadium and the ground underneath the helicopter. So what you're going to do is you have to figure out what you have, and you try to cut that out. Ready, cut. All right. So now what you're going to do is you're going to try to find one variable at a time. So for now, let's try to find the y. So we know that we have the opposite. We have the opposite. We have the adjacent length, but we need to find the opposite. So what we're going to do is we're going to do tangent of 63 degrees equals y over 1,000. Those look like sixes, but it's kind of hard to draw. I know. So basic algebra skills, you're going to multiply by 1,000 on each side. And then we throw that in a calculator. Tangent of 63 times 1,000. So then you're going to get about 1,962.6 feet. Feet. So y equals 1,962.6 feet. Okay. So now you know the distance between the baseball field and the ground underneath the pilot. So now we're going to do the same thing, but with the football, from the football field to underneath the pilot. So you got tangent of 18 this time equals x over 1,000. So just like over here, you can just throw that in the calculator. We get about 324.9 feet. And then you're just going to add those together. So that on a calculator because I'm lazy. So then you get about 2,200. 2,287 and a half feet. So that's how you solve those kind of problems. Alright. So then next up, we're going to find the 6 ratios for angle F. And then we're going to find angle F. So what we're going to do, we have our right triangle right here. We have 17, 15, and whatever that is. So first what we need to do is we need to use a Pythagorean theorem to try to find this missing variable. So we got a squared plus 7 squared equals 15 squared, which will be a squared plus 49 equals 225. So subtract that over. And we're going to get 176. And we square root that. Then that's not a great number. So what we'll do is we'll just leave it as a equals square root 176. So now what we're going to do is we're going to try to find all 6 of these trigonometric ratios. So sine of f is opposite over hypotenuse, so square root 176 over 15. Cosine, it would be 7 over 15. And tangent would be square root 176 over 7. So now that we know those, it's pretty easy to find secant, cosecant, and cotangent. It is literally just the reciprocal of each one, except it's not negated. So secant of f would just be 15 over 7, and then cosecant is 15 over the square root of 176, and then cotangent is 7 over square root of 176. So now that we know the 6 trigonometric ratios, what we're going to do is try to find f. So the best one we could use is probably cosine. So cosine f equals 7 over 15? 7 over 15. So what we'll do is we'll take cos, and then we'll just do cosine of negative first times 7 over 15. So when we put that in our calculator, cosine of 7 over 15. So then f will be equal to about 62.18. 62.1 degrees. There you go. Simple as that. So now, next up, so that obviously means we're going to use tangent. So tangent of r equals 7 over 10. And we'll use the inverse of that. So r equals tangent of negative 1 times 7 over 10. So when we put that in our calculator, we use tangent of. Now we're going to get about 35 degrees. So r equals 35 degrees. There you go. There's 9. And on 10, r equals 12. So 12. And t equals 20. What is s? So we're trying to find this angle. So now we're not going to use tangent because now we don't have the opposite side. So now we're probably going to use cosine to find s. So cos s equals 12 over 20, which also equals 3 over 5. We'll come back to that. So then we got s equals cosine to the negative first times 3/5. Just do that times 3/5. Alright, so we do get this. I'm good. Alright, so then we got 53.13 as our final answer for s. S equals 53.13 degrees. And